Okay, question 1D. So the reflection of the point 1, 0 in the line y equals mx has coordinates 1. Okay, this looks like a fun question. Okay, so again, coordinate geometry, right? Diagram, please. Okay, so 1, 0 is here. And you know, y equals mx doesn't matter, okay? Just assume positive m, okay? It doesn't matter. All right, so now what happens is that, okay, I sort of, okay, this has to be perpendicular, right? Because, you know, it has to be a reflection. And I sort of want this point here, which is out of nowhere, right? Out of nowhere. Okay, so proposal is that, you know, find this point, right? If I find this point and then I just double it, right? Just concept of vectors going on, right? So find the point of intersection there and then double it, fine. Okay, and the thing is perpendicular, right? So what sort of thing do we want to attempt? Well, probably the dot product, right? Okay, so well, let's call this point, I don't know, doesn't matter, x and mx, let's say. Okay, that point is x and mx, right? So okay, maybe I shouldn't use vector notation because it's a point, right? It's coordinates, so maybe x and mx like this. Okay, so well, vector, well, x mx, that's the vector here. Dot what? So dot well, whatever really. X minus 1, let's say. X minus 1 mx here. Oh, is that correct? Yeah, that's right. Okay, so here this should equal to what? This should equal to 0. Okay, this should equal to 0. Okay, now let's solve the equation. So we're saying that, okay, it's moved for some reason. So we're saying that x times x minus 1 plus m squared x squared equals to 0. Okay, is that solvable, or that's more than solvable, right? So x equals to 0 is just not a legit solution, right? X equals to 0 is dumb. Okay, so we could cancel out the x here. So x minus 1 plus some m squared x equals to 0. Okay, so what does x equal to? X equals to 1 on m squared plus 1. Cool. Okay, so that's the point. Okay, so x is 1 over m squared plus 1. So mx is m over m squared plus 1. Okay, but we want the reflection, right? We want the reflection. So what we want to do is that, okay, we want 2 times that distance, right? We want 2 times that distance. So basically we have what? 1, 0 plus 2 lots of what vector? Okay, maybe I should use vector notation here again. Okay, just that's a precision vector, right? 1, 0 plus 2 lots of what? Okay, we have to be careful with the direction this time. Okay, the direction actually matters this time. So 2 lots of 1 on m squared plus 1 minus 1, right? And what's the next one? M on m squared plus 1. Okay, so we actually have to take care of the direction this time. All right, now get rid of this line, okay, because it's taking up space. All right, so what does that give us? That gives us 2 over m squared plus 1. And well, that's minus 2 plus 1, so that is minus 1. And bottom is 2m over m squared plus 1. Okay, and you know, if you want to simplify the top, what does that give us? That gives us, what is it? 1 minus m squared, right? Is it? Yeah, I think so. Over m squared plus 1. And below is 2m over m squared plus 1. Okay, so let's see if that's one of the answers. Aha, that is D, isn't it? Okay, so cool. I think dot product is a really cool way of doing this question. It's quite nice, you know, and vectors in general. Okay, I think there might be other ways to do this without vectors, but I really like vectors. All right, so vectors is the way I would go for, and the equation does resolve nicely. Okay, so cool. Answer is D. Lovely.